Polynomials. The first thing here was we're starting with the very beginning of the chapter. So this one, you guys are going to write these into the standard form in descending order. So everybody, these two problems, write them in descending order, please. When we ever in the standard form in descending order, that means the highest degree is going to be first. In other words, the one that has the highest. And here, what is the one with the highest degree?
7x squared.
Negative x cubed. Doesn't matter. Still the one with the highest degree. So we have negative x cubed plus 7x squared plus 8x minus 4. But descending order. Descending order means we're going in the order of their powers. So 3, 2, 1, 0. Now remember, you also have to look, do we have to simplify terms? In other words, maybe we had more than one x cubed term. We have to get down to one x cubed term, one x squared term. So sometimes, now neither of these problems had that, but it might be a case if we had like another, say, plus 8x squared, we'd have to get that down to one x squared term before we could do our descending order, like that. But in this one, what is our highest degree of term? Actually, we do have that, right? We have negative 7x squared and 4x. So what is? So we're going to have basically we have x to the fourth minus 3x squared minus 4. So once we only have one of each term and degree, now we can put them in order, descending order. Well, we have x to the fourth minus 3x squared minus 3x minus 4. Does it matter that we don't have an x cubed in this one? No. Doesn't matter that we don't have an x cubed. But you are going to have to combine those degrees. Questions about that? So remember, degree of term. Now this one, you're basically going to factor these, and you're going to find the one that is missing. All right, so let's spend a few minutes and factor each of these. By the way, that should be an x squared right there, not an n squared. It should be an x squared. All right, so let's spend a few minutes, factor those, use your diamond box, and find the missing number. Now we always multiply the a times the c number and put the b number at the bottom. So we have 1 times negative 5, so we have a negative 5 and a negative 4. Now the factors of negative 5 is either 1 and negative 5 or negative 1 and positive 5. Which of these is going to add up to give me a negative 4? The first one. So I get 1 and negative 5. So if I have my box, x squared, negative 5, 1x, negative 5x, I can factor out a positive 1 and a negative 5, which means what belongs right here? Negative 5. Negative 5. Shh. Questions? Over here, again, we have 1 times 10, so we have a positive 10 and a negative 7, which means either both my factors for 10 have to be positive or both are negative. And since this is a negative number, I'm not going to worry about the positive ones, so I have negative 1, negative 10, negative 2, negative 5. Which of those are going to add up to be negative 2, negative 5? So when I make my box, x squared, 10, negative 5, negative 2, x. So I can factor out a negative 5 here, negative 2 there. So what goes in the box? Negative 2. Negative 2, like that. Question? David, do you have a question? Stop talking, please. You distract the people around you. our last one on this page, again, 1 times 22, put 22 up here, we have a 13. It's all positive. We worry about negative positive factors, so I have 1 and 22 and 2 and 11, and obviously it's the 2 and 11. So since I have the 11 here, I know the other one's going to be the 2. Janelle, could you take the chair and sit outside, please? David. All right. So, this one. You guys are just factoring out the greatest common factor of all these. The greatest common factor. So factor out these greatest common factors. You're not asked to factor to binomials, just find the greatest common. So let's look at this. What number can I factor out of that?
20.
I can take a 20 out of both. So 20, z divided by 20 is just z. 100 divided by 20 is 5. Now remember, if you don't quite do it, you could go to the common factor, but you could do this in steps. Because both are even, I can always factor out a 2. Remember, an even number. So if I took this in steps, 2 times 10z plus 50. Again, they still have even numbers, so I could factor out another 2. I could take out another 2, which would make it 4 times 5z plus 10. 5z, no, I'm taking out 2, plus 25. Thank you. Getting ahead of myself. Plus 25. And when I get to that point, I can now take out a 5. And when I move the 5 to the front, I get that 20z plus 5. Okay, so you could do it in steps if you don't recognize that greatest common factor. Think about it. Can it be divided by, both divided by a 2, both divided by a 3, and things like that. Number 7, I can take out an 8. So I get 8 times x minus 16. Excuse me, 2. Thursday. All right. On this one, well, first of all, what can I take out of both? Don't worry about the coefficients. What about? I can always take out. Here I can take out an x, right? So I have an x to the first, x to the third, x to the fourth. I can take out an x out of all of them, which makes my x parts plus something. And then but I can also take out a 4, which is going to get x cubed plus 2x squared plus 4. Plus 4. There's no x cubed. There's no x squared. So it becomes x cubed plus 2x squared plus 4, like that. Over here, well, 1, I can take out a 3. I can take out a x cubed, right? Because I have an x to the fourth and an x cubed. I can always take out the lowest term. So I can take out an x cubed, and I can also take out a y. Only one y. So that leaves this first term, well, take out 3 at 0. Basically, I get x, y to the 7th plus 6, like that. Because basically I took the x cubed y, like that. Any questions about the greatest common factor? Y to the first, so 8 minus 1 is, when I took out 1y, I lowered that by 1. All right, questions. Remember, this is the first step in factoring. Taking out anything I can take out right in the beginning. All right, factor these two completely. Use the box, diamond, and box. Show your work. Or if you're not using it, at least factor. Show me that you've done some work. Just don't put out an answer. Okay? You guys are also in very close quarters. You guys show that you did the work. So if you factor it, just show the factors. I'll know, hey, you did some work.